When two lines are in a plane, such as the piece of paper in front of you, one of the possibilities is that those two lines never intersect. When they never intersect, the lines are parallel. In order to prove that we have parallel lines, we need to show that those two lines have equal slopes. Another possibility for two lines in a plane. Those two lines could intersect. And when they intersect, they form a 90-degree angle. When two lines intersect to form a 90-degree angle, they're perpendicular. In order to prove that two lines are perpendicular, their slopes need to be opposite. One slope has to be positive, and one slope has to be negative, and the slopes have to be reciprocals of each other. A third possibility for two lines in a plane is when the lines aren't parallel and aren't perpendicular. If they're not parallel, that means that the two lines intersect. If they're not perpendicular, this angle created is not a right angle. Two lines that are not parallel and not perpendicular are called oblique lines. Looking at example 1, we're given two lines that pass through some ordered pairs. Since we're given ordered pairs, we're working with coordinate geometry and we want to use formulas. Step 1, I'm going to plot the points that line 1 goes through. -5, 9. And 0, 5. Line 2 passes through -2, -5. And 6, 5. Now if you look at these two lines, it doesn't even look like they intersect. But if I connect the points all the way across my paper, I can see that those lines do intersect. And just by looking at it, it looks like those two lines should be perpendicular. It looks like this intersection is a right angle. But I need to verify my answer. In order to verify my answer, I need to use slopes. The slope formula is y2 minus y1 over x2 minus x1. So step 1 to verify, find the slope of line 1. (5 minus 9) over 0 minus -5. 5 minus 9 is -4. 0 minus -5 is +5. A negative divided by a positive is a negative number, and 4 divided by 5 is just 4/5. So the slope of line 1 is negative, and we can see that because it falls to the right, and it has a slope of -4/5. Now we need to find the slope of line 2. y2 minus y1 over x2 minus x1. 5 minus -5 gives me +10, and 6 minus -2 gives me +8. So I have a positive number divided by a positive number, and 10 divided by 8 in lowest terms is 5/4. So if I look at my slopes, one's negative, one's positive, so they're opposite, and they're reciprocals, 4/5 and 5/4. So I can conclude that line 1 is perpendicular to line 2. Since their slopes are opposite reciprocals. Whenever I need to verify my answer, I need to explain how I came to that conclusion. This is that explanation that explains all of this work. Second example. Write the equation of line 2 in slope-intercept form. If you remember, slope-intercept form is y equals mx plus b. In order to write the equation of a line, I need to first figure out the slope of the line. So step 1, find the slope. In this case, how do I find the slope of line 2? Well, if I'm given two ordered pairs, I can use the slope formula. Well, I've already done all of that work. I know the slope of line 2 is 5/4. Step 2, after I found this slope, I need to find my y-intercept. In order to find my y-intercept, I have two methods. My first method is known as the point-slope formula. The point-slope formula starts with y and subtracts y1, and it's equal to the slope of the line times x minus x1. So I plug in what I know. y1 for line 2 is -5. The slope is 5/4, and x1 is -2. Now I simplify. Y plus 5 equals 5/4 times x plus 2. Now I need to distribute this 5/4 into the parentheses. Y plus 5 equals 5/4 times x plus 5/4 times 2. In order to multiply a fraction by a number, I'm going to make this 2 a fraction and multiply straight across. 5 times 2 is 10. 4 times 1 is 4. So my answer is really 10/4. Well, I can simplify 10/4. So I have y plus 5 equals 5/4 x plus, these are both even, so I can divide both of these numbers by 2 and get 5/2. Last step, solve for y. To solve for y, I need to get rid of this 5 by subtracting 5. Well, how do I take 5/2 minus 5? I'm going to do that math right here. I have 5/2 and I'm going to subtract 5. In order to subtract fractions, I need a common denominator. The common denominator between 5/2 and 5 is 2. Well, really, this is 5/1, so I need to turn 5/1 into something over 2. Well, I multiplied the denominator by 2. I better multiply the numerator by 2. 5/2 minus 10/2 is going to be 5 minus 10, subtract my numerators, keep my denominator the same, which is -5/2. At this point, I'm left with y equals 5/4 x minus 5/2. If you look, 5 halves is negative 2.5. If you look at my graph, my y-intercept is negative 2.5 for line 2. Let's look at method 2. Method 2 starts with what my answer should look like. Y equals mx plus b. Step 1, plug in the slope, 5/4. And this method uses the fact that I know some ordered pairs. I know that when x is negative 2, y has to be negative 5. So I'm going to use that fact, and I'm going to plug in negative 2 for x. I'm going to substitute in negative 2 for x. And when x is negative 2, y has to be negative 5. So I'm going to plug in negative 5 for my y. Solve for b. Negative 5 equals 5/4 times 2. Well, I've already done that math right here. 5/4 times 2 is 5 halves. In this case, I get a negative 5 halves. To solve for b, I now need to add 5 halves to both sides. What is negative 5 plus 5 halves? Well, I've already done that math here too. I have 5 halves minus 5, which is the same as negative 5 plus 5 halves. Negative 5 plus 5 halves is negative 5 halves. So b is negative 5 halves big. The trick on method 2? Well, I'm not quite done yet. I've solved for my b. I still need to write the equation. My final answer is y equals 5/4 x minus 5 halves. Notice both methods give me the same answer, and I can check my answer by looking at my graph. This line does have a slope of positive 5/4, and it does have a y-intercept of negative 2.5, negative 5 halves.